And hello, everybody. Oh, sorry. I should have avoided the shock and covered my face. I get a shock every time I see myself. Yeah. I don't like it. But it is good morning from me, and
it's good morning from him. Good morning.
good morning. Yes, good morning to everybody. I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. Good morning. Well, YouTube is reporting an excellent connection, which is a good way to start the day. It may seem like I have a reasonable energy level right now. I am totally faking this, 100% faking this. Good morning to Alistair, Cable Tie, Christopher, David T, Dodgy is here, Don S from New Zealand, Incognito, Henrik, one of the two Henriks. We have Henrik Holtberg, and sorry, my list just jumped. Imi, Jackstech, Jordan, Keith H, Mike, Mitchell, Crispian is here, POD line, Podline, POD line, don't know. Russell, Scott, some call it fun. Stephen W. Stephen, maybe you'll be coming along to the barbecue today. I don't know. Doubled up audio. Really? Maybe that's just because both microphones are picking me up. Maybe I am about 300 millisecond delay-ish. That is interesting. The audio is you. Stephen, you're making me panic, making me think that something was wrong. Who have I missed? I haven't yet caught up with Todd, Wagon Loads, Amanda, Austin, Gavin, Michael, Stephen George, David, Mark Laguda. Iggy is here. Right. Stephen, you had two streams going, so you were contributing to my viewer count. That's excellent. Everybody open a second stream right now. Grab a phone or something and start the stream.
Amanda Thompson said, which Fury friend do you have on the back of your chair?
You've seen Steve's butt.
Oh, that's Steve's butt. Okay.
Welfare check.
Welfare check,
All
yeah.
Right, there's Steph.
Yeah, Steph is there.
The rumours are not true. They are squirrelous rumours.
Squirrelous rumours. Yes. I'm bouncing just yet, but getting there. Okay. Sorry. That was like half a sentence that I just said. Random words that made no sense out of context. So earlier, Michael said that he was recovering from a health hiccup and not bouncing just yet, but getting there. That's good to hear. Yes.
And for our northern friends, John.
And northern friends.
It's pretty warm today.
It is pretty warm today, yes. Those of you who are not in Melbourne, it is heading towards, 36 or something? And it's probably not a whole lot off that already. And it's only 10 in the morning. Scott says, moon's by a squirrel. Legit. Okay. Now, last week, so I'm going to do a quick little callback to last week before we get into KiCAD. So what we're going to do today with KiCAD is do the routing that I kind of just started playing around with last time, and our goal is production files. Mitch told me that there is a plugin which is really useful for helping to generate the production files and also referencing LCSC part numbers and things, so that it makes it simpler once you come to the assembly portion of things. And that sounds really interesting, so I've got to definitely check that out. Michael says 32 in Geelong already. Yeah. And you're down near the sea, by the seaside. But last week I talked about testing and the Testimator board that I've been working on. So let's go for an overhead view. And we are going to slide back over this way. So I'll show you this thing. This arrived and I assembled it during the week. the screen that you can see on the front, that is this is a Raspberry Pi and a touch screen, 5-inch touch screen, I think, with a resistive touch. It's only resistive, not capacitive, unfortunately.
Austin's_creations said don't use the Gerbers from the plugin, it'll do intended vias last time I tried.
Oh, okay. Thanks, Austin. We'll I'll do untented.
Austin's_creations said don't use the Gerbers from the plugin.
Yeah.
It'll do intended vias last time I tried.
Okay. We will talk about that when we get there, and explain tented and untented vias and all that sort of thing. So this is the controller that I had, like the Octoprint controller that I had on my second 3D printer, which I haven't even fired up in a couple of years. So I pulled it off, used it for this purpose. This is the Testimator board that I showed the design for in the last stream. There's a Raspberry Pi Pico in there with a CAN bus shield under it. There's a power supply under the front. Power comes in here. In fact, what I should do, okay, everybody put the mute on your voice assistants. Alexa, turn on power supply 2. And power supply 2 is currently set to 24 volts, so just make it
I'm really tempted to clap to
12. The clapper.
as in a single something blowing up clap.
Oh, right. Yeah, to make me jump. Oh, you did it. That's an electrolytic capacitor going. Okay, so
The tantalum chucked a tanty.
yeah. So I've just turned on power. So power comes in the side from the lab power supply, and then these are the different.
Mitchell R said not enough time to reach my speaker, haha.
Sorry, guys.
And these are the different I/O things that go out to the test board. So the idea is there'll be a breakout on the back here that the test board mounts onto. So that's where the Pogo board is going to go. And you can see here the ADCs, the DAC, the power monitoring, the relay that's power control for the device under test, etc. And why isn't this booting? Do I have it plugged in? Oh, it looks like it's, I don't know what's going on.
Green lights flashing.
Yeah, I don't know why I have no video. Maybe this is going to be a big demo fail.
It's the demo gods.
Oh no, the green light is flashing. We just have no display. Not that we need a display. I actually haven't even been using the display. I'm just going to switch over to a terminal that I will show you in just a second. Yeah, it's up and running because I can SSH to it. Well, maybe I can SSH to it. Yes, I can. But it's being very slow, so it's probably still in its getting booted
I
stage.
think people are still seeing the board.
Yeah, they're still seeing this. Yeah. Why am I not getting a terminal? This could be a whole big demo fail. Anyway, what's meant to happen? So you can see that it's sitting on a laser cut base, and I have here the receipt printer, and the receipt printer is set up to connect to it, and then it can do things like use this ESP flasher to load firmware on a target board and print out a test receipt, and most of that is actually working. So I don't know what's going on with that Raspberry Pi. I SSH'd into it and now SSH is not responding. So this, that's very strange.
It's half working, John.
It's half working.
How does something half work?
I don't know. I can SSH in, but then the console is dead. Like the terminal is dead. So I'm just going to let it sit there.
Flash?
And think about its life choices for a while. And in the meantime, we can start looking at some KiCAD stuff. So maybe we will come back to that. I'll get out of that. Oh, what happened there? And now somehow it is up and running. So, okay, I'm going to, what am I going to do? Test. All right. This is really crude. This is just my quick some rough experiments with it. What I've got is a test script. This is just a little Python thing, which all it does is load up the flash onto the brownout can cause that on pies. Oh, maybe it was a brownout. That's possible. So what I'm going to do is, sorry, I'm looking around to try to get myself organized. What do I want? Overhead. Okay, here we go. We have the test board. Should be better if I could zoom out. Let's see if I think this may be zoomed all, yeah, it is zoomed all the way out already. Can't get any bigger picture than that. But what I'm going to do is plug in a board. So just imagine that this is the board that needs to be tested, needs firmware loaded on it, all of that sort of thing. Turn on the printer. So, how can I get all of this in the screen? Alright, close enough. I'll get that there. You can just about see everything. Alright, and the other thing is the barcode scanner. So, what I'm going to do is run this test program here. So I'm going to hit go, and what it wants is the serial number of the device under test. Now for that, what I'm going to do is zap the barcode, and it now has the, well, it should have, maybe. Why did it not see that keyboard? Oh, I know why.
Yeah.
I know why. I'm being silly. All right. Please excuse what's going on. Okay, so I zap the barcode. The tester now knows the serial number of the device. It's reflashed it and failed to print.
There was a bit of a Christmas tree there for a moment, John.
It was. On here.
Here. Red and green lights flashing.
Yep. Do I have the, is that the printer? Yep. Oh, the Christmas tree. Yeah, that would have been the programmer. Oh, there it goes. Okay. So that was delayed. Oh, it hasn't finished yet. Yeah, I think this Raspberry Pi is browning out or doing something stupid. So what it's done is it has half printed the test receipt. You're probably not going to be able to see it, but it's got the device that was tested, the serial number, the hardware version, the firmware version, the fact that it was me that tested it. There's a timestamp, it's a note saying installing firmware, and then it's got a list of manual checks that need to be performed and signed off before the board can go out to the customer. So, oh, hello. We have a ring in. Hey, Crispian. We have.
G'day, mate.
G'day all. Where's it?
There. It's that one.
Oh, okay.
So I'll switch back to the front camera.
G'day people. Imogen's outside just cooling down after the crazy drive.
Yeah.
Sorry to interrupt. So did you get the Bitbook thing working?
Yes.
Sort of.
Sort of. Sion said, is a barbecue day today? Yes, it is. But it is so hot that
Crispian?
I'm not looking forward to starting the barbecue.
I'm all good.
Whew. All right, so let's give up on messing around with the test tomato and get into KiCAD.
Doing some proper work.
Okay.
You may have heard we've got a live stream going.
Oh, is that what you're doing?
All right, so on to the PCB. I've got to refresh my memory as to where we were up to 2 weeks ago. Ah, that's right. We were at this point. We had some basic parts put down.
I think we put in a zone as well, the
Yes,
fill
the
there.
background was it?
Yeah.
Background, yeah.
Yeah. Okay.
And I remember asking the question about capacitance between the two.
I'm going to bring up the Funway PDF, if I can find it.
It's on a cool drink, John.
I've got one, thanks.
Keith?
And there. All right.
No, no thanks.
So this is where we were at last week, I believe. We got the schematic, we got the PCB, and the rough layout here. So, I have questions. Zion said, isn't it a total... I hadn't even thought of that. Total fire ban today, no barbecues. Yeah, gas barbecues, and it is inside. Yes, inside-ish. You're right. It is in the loading dock of my factory, essentially. So it is inside. Yeah. All right. Now, the first big decision here is setting the outline of the board, the dimensions of the board. So we've got a rough shape, which was made just by drawing the outer dimensions of the board, but there was no particular size. So this is where I need to learn a bit about how things like coordinates work in KiCAD, because the way Fusion does this, there are fixed axes, X and Y, with a 0 point that doesn't change. And from what I've seen of KiCAD, you can reset the origin. When you reset the origin, is there still an absolute origin anywhere, or is the origin the place that you have set?
I'm not exactly sure. I think Sion might know this better than I do.
Okay.
There is a canvas origin of 0, 0 up in the top left-hand corner, so Y increases down the page rather than going up as it would for mathematics.
Right.
You can press space to set an origin if you're kind of eyeball measuring stuff.
Mm-hmm.
So that's your relative coordinates, and you can also place an origin there, but I'm not sure whether it might just affect how drill files and the track information that the Gerbers are done.
Mm-hmm.
I think there's an S key will place that origin. So if we went to the corner of the board and pressed S, I think.
Now, should I do this in the bottom left or the top left, given that Y goes down?
When it publishes drill files and Gerbers, that's positive going up.
Okay.
So I think
Good. Yeah. So having the origin in the bottom left corner makes the most sense then. So positive to the right and positive going up once we produce the Gerbers.
Let's see.
Okay.
We can always move it.
Yeah. All right. Now, the other thing
What
is...
I often do is I'll pick an arbitrary coordinate like 100, 100, and put the corner of the board in there.
Mm-hmm.
And then I can quickly, when I mouse over everything else, just mentally subtract 100 to give me an idea of relatively where it is on the board.
Yeah. Now, it's probably quite hard to see on the screen, but right down the bottom of the screen, just below the cursor here, where I'm waving it around, it's got X at the moment 81, Y minus 120. And if I move the cursor up, that Y number is heading up towards 0. And 0 on X is off to the side somewhere. So the actual 0 point right now, if I go left, 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 is over here to the left. Oh, it's right on the edge of the page. And up, oh, there. Okay, so that makes sense. It's on the corner, top left corner of the page. That is currently 0, 0. So we've got the whole sheet here, and then the frame is somewhere inside it. So what we could do is, this is something I'd never really thought about. This is showing a sheet with all of this other information around it, even though we're in PCB mode, and it's showing a page border, which is not at all how Fusion does it. So, like, this is normal for schematic. You would have, because typically a schematic you need to be able to print but with PCBs they're usually not bounded by a specific paper size, and it's got the frame on it, which is a bit odd. So is this normal? Is it usual to have a frame with PCBs in KiCAD? Or is this something that's been added by just by default?
I don't know. I'd have to check on my computer. I can tell you where this stuff is set. So there's a settings thing. Yeah, right. I mean, I've seen it in schematics. I don't recall seeing it in the board editor, but maybe that's because I wasn't paying attention.
Yeah. Well, Stephen just said first time I've seen that in KiCAD. Scott pointed out you can print the PCB sheet for use in manual assembly. Yes, and JackStack says it's normal. Oh, okay.
Let's have a look at the settings there.
Yeah, under KiCAD settings.
I think it's under File. Where are I?
PCB editor.
Drawing sheet editor, I think.
Drawing sheet editor. Display options. Grids. Snap to grid minimum. That's just grids and colors, which is not very useful.
So maybe not. There is a way of saying which template you want to pull in.
JackStack said usually we are so zoomed in it's not on screen. And Sion said, yep, it's normal to have it. You can make custom ones or use defaults. That's interesting. Yeah, very strange. Because it's not unusual for me to make boards that are physically bigger than the dimensions of an A4 page. Like things like the RJ45 breakouts are very long. They would not fit within this page. So
you can set the page size.
Okay, set it to A3 perhaps.
There's an option in the Gerber generation that says whether or not to...
Unexpected Maker said it's in the page setup menu, not settings.
Yep. Page settings. Here we go. A4. Landscape origin. Orientation landscape. Yep. And you can do custom paper sizes. Alright. Well, for now A4 is fine. This just threw me a little bit because I'm not used to seeing
that
frame.
dialogue that was just open there is where you edit the information that occurs in the bottom right hand corner in the title block.
Right, so we've got issue date, revision, title, company, etc. And that gets inserted down into here.
There's a little arrow there. If you click on it, it'll insert the current date. I believe you can also put variables there.
Yep. So if I go to page settings and I'm going to put Funtronics as the company, even though there is no company called that. And if I click that, it inserts the date. But yeah, maybe there are variables like, I don't know, I'm just going to make this up, but like date or something. I don't know what the syntax is. But if we just insert today's date, revision, title, Funway, Volume 2, Project 1, maybe? Oh no, that can be a comment. Let's make the title Blinking LED. Okay, and it's inserted it into, into that information frame. JackStack said it's a drawing/drafting standard to have that border.
Sometimes customers would send me Gerber files that had the border in it.
And would you then, when you generate the Gerbers, presumably this is on a layer that doesn't get processed?
Factories just throw it away.
Yeah, okay. Alright. So, anyway, yeah, that's right. Back to the origin. What I would like to do is, so if I, and then, is it G for drag? No, it's different between the schematic and the PCB editor. I don't want, or if I do M for move, I can move all of it because I've selected it all. I'm trying to get into my brain the keyboard shortcuts. If I'm over this capacitor, for example, and I do M for move, it's going to disconnect it from the tracks. And if I do G for drag,
you want D for drag.
oh, D for drag. Okay, so it's G for drag in the schematic and it's D for drag in the... Yeah, okay. That didn't rubber band. Anyway, my brain is not in a shape to be dealing with this right now. I need to explain to people what's going on. I somehow injured my shoulder on Tuesday, and I don't know how I did it, but I've been in a significant amount of pain since Tuesday, which means that I have not had very much sleep, which means that right now I am in a very strange mode where I am struggling just to function at all, and trying to learn new stuff is not good in this situation. I keep being distracted by the pain in my shoulder and not being able to think properly. What was I doing? I don't even remember. I've lost the plot. Okay.
So you had a quick refresh of move versus drag, and I'm guessing what you were going for is working out where to put the board, and also sizing the board.
Yes. Now,
if it was me, I'd be looking at sizing this board so that I could get JLC's 5x5 special.
okay. Now, the original board had two very specific properties about it. One is that all of the routing was done in a circle so that it could be cut like with a pair of tin snips or something. You could cut it into a circle so that you could make this brooch sort of construction. And the second was that the dimensions of the rectangle that contained that circle were the correct size to go into a standard plastic project box that you could buy from Dick Smith.
Creations set for an electronics intro board. Wouldn't it make more sense to do ground traces vs fill?
Austin, that is a very interesting point, and I will very happily debate you on that in just a second, because I want other perspectives on this. I'm undecided. I have thoughts on that subject, but we'll get to that in just a second. So what you can see here is this is the original PCB layout. It was designed to fit within this circle, whatever that diameter happened to be. But it was in a rectangular board, presumably also because back when they were manufacturing these PCBs, which was in the 1980s or whenever it was, things like milling of odd-shaped boards was probably not as commonplace and straightforward as it is now. They would have been cutting the boards apart out of panels, possibly with circular saws or that sort of thing. So the board was produced as a rectangle and designed so that it could slot into this standard black project case. So one of the decisions is this is kind of a meta question. It's a question about the overall goal of reproducing these projects. Is it to reproduce the original, or is it to do something that moves on from it and is more like doing honor to the original?
Are we cloning or are we teaching?
Yes. And this also comes down to Austin's point just a moment ago. Yes, Austin says move on from it. And David says move on with modern design methodology. Yes. Okay. So that then brings up Austin's point, which is about a ground plane. And I am very much in two minds about this. When I'm designing boards, I exclusively, I say that hesitantly because there may be exceptions, But I will say
He does, except for when he doesn't.
Yeah, that's right. Except when I don't. I use ground planes, and there are a few good reasons for it. One of the reasons, so back when I was making my own PCBs and I used to etch them with ferric chloride, the more copper you take off the board, the more rapidly your ferric chloride becomes contaminated, doesn't work. And to some extent, there is a similar consideration at a PCB factory. The boards are made with complete 100% copper coverage, and then wherever you want there to be not copper, it has to be chemically etched away. And etching it away then uses up the chemicals that do that. Now, to some extent, there is a little bit of recycling, etc., of the chemicals, filtering.
They recycle the copper as well.
Yeah, so they recycle the copper that is recovered off the board, which is good. But just as a general principle, I follow the basic principle of don't remove it if you don't need to. Just leave it there. And doing a ground plane means that the vast majority of the copper ends up just staying on the board.
Scott Miller said ground traces were good back when boards were hand-drawn. Not so much now.
Yes. So ground traces were good back when boards were hand-drawn, not so much now. And yeah, so it means that you automatically get the benefit also of basically all the parts on the board, well, all of the major parts on the board are going to need a ground connection. ICs will, a lot of other parts will, pull down resistors will, an LED that goes to ground will. So ground is probably the number one most common connection, the most ubiquitous net that will go everywhere on the board. So having a ground plane on the surface of the board makes connections to it very easy. And
if you're doing digital circuits, it's also very useful to have that ground plane to stop things like ground loops and stuff. But something like this, you don't need a ground plane for the point of signal integrity.
That's right. So we're not really concerned about signal integrity. However, this is where my hesitancy about using a ground plane on this board comes in. Because if we look at the schematic, I've got to remind myself, no, that's the update. Where's the schematic? Show 3D. Don't help me, there. I need to start learning where some of these shortcuts are so that I can just do them automatically. Alright, so if we, for example, attached a, in fact I'm going to, so it's normally A for adding a part. Is it P for a power symbol?
Yeah, that's right.
P. Oh, my memory worked.
Yippee.
Amazing. Okay, so I just hit P and it popped this up, and I'm going to go to, where is it? G. I'm just going to hit G. Hopefully that'll find it. Ground. There we go. This will do. So I'm going to stick a ground on there. This is the negative side of the battery, and we have the two transistors connected to it. Nothing else on the board is connected to ground. So what we could do is have a ground plane on the PCB, and then one of the battery terminals would connect to it, and one terminal from each of the transistors would connect to it. We wouldn't need to explicitly route that trace. So if so here we can see, for example, the negative side of the battery is connected to that ground plane, and we can see that pin 3, which I think is the emitter, I can't remember which way around these are. Yeah, that'd be the emitter. Of
CBE,
each of the,
I think.
Yeah, CBE, collector base emitter, of the transistors goes to the ground plane as well, which means I do not need to explicitly route that track. It saved me from routing from there to there, and then from there to there, which is a very minor saving, and you don't really get the big benefit that you would in a more complicated circuit. So this comes back to my debate point, which is do we use a ground plane here, which to some extent hides that signal when I would like that signal to be
Austin's
explicitly
underscore
visible?
creations said hit F8 to update the board and net names.
Yeah.
F8, okay.
It's very useful.
Austin's underscore creations said hit F8 to update the board and net names.
All the says are coming through twice. I don't know why. Update PCB. I'm not even going to read it. Just did it. Okay. So, yeah, it now says ground instead of whatever that thing was before. V negative or something. I can't remember what that net was before.
Are you soliciting inputs, John?
I am soliciting inputs because I keep flip-flopping. Now, what I'm trying to convey here in terms of presenting this project to a beginner.
Mitchell R said check you don't have another tab open.
Oh, check I don't have another tab open. I don't think I do.
Maybe we can close that one and then try a say.
Yeah. Oh well. Whatever is happening is happening. Iggy said, leave it as a ground pour because that is what they will see as they progress as well.
Mitchell R said testing single tab now.
I'm waiting for the second. We don't have a second yet. Okay, I don't know what's going on.
I'm waiting for the other shoe to drop.
Yeah. All right.
I'm going to weigh in here.
Okay.
The first board, you want to have as few concepts that somebody has to grasp as possible. I think ground planes are great. I use them all the time as well. There's good reasons to have them there as well as convenience. But on the first board, you want to introduce them to as little as possible. I wouldn't have it.
Yes, that is the way I'm leaning as well, because I see a ground plane to some extent as being like an abstraction. It's like an invisible signal that is everywhere on the board. It's there because the plane is there, but to a beginner, it might look like half the circuit is missing. They would look at this and say, oh, power comes out of the battery here on the positive side, but there's nothing connected on the negative side. Like it somehow transports through hyperspace. And they don't understand that the entire front surface of the board is that net, and that is available anywhere simply by connecting to that top piece of copper on the board. So I see that as being something that makes the circuit less obvious. So yeah, my inclination is the same as what you're saying, which is explicitly show all of the tracks and the signals and the way they go.
I'm thinking of the Python adage, explicit is better than implicit.
Yes, explicit is better than implicit. Yeah. I'll try to catch up on a couple of the comments here. So Stephen said, I think it is traceability. It is much easier to follow a trace and what it goes to compared to a fill. For someone learning this makes understanding how the board is designed from the schematic. Yes, exactly. Jackstack said you can have it there and describe it as a big wire. That's true. And Stephen asked, is the assumption that this is intended for children and up? Yes, it is. The appeal of the original Funway series was kind of higher primary school through secondary school sort of level. The first Funway, which was totally solderless, Funway Volume 1, that could be done by primary school children, like grades 5 and 6, shouldn't have any trouble with it. And then this sort of board is useful in, for example, a science class in high school. So
I think anybody who's a newcomer to this is a way that I was always wanted to get into this. Well, this is the fun way to get into it.
Yeah. Austin said, could make it a fill, then just use a ground trace, thus the fill isn't actually connected. That's probably what I would end up doing if I put a trace on here. I would probably, I don't know, I'm undecided about that as well. So that would end up with a big copper pour that is not connected to anything, that is not electrically part of anything.
That doesn't feel right.
So it doesn't feel right. And it could also be confusing later when a ground plane is introduced, because for some of the more complicated projects that are later in the book, there would be far more of a benefit. So with this particular schematic, like if we're looking at this circuit here, we've got only those two connections to the negative side. But if we scroll down, I'm just going to find a random project further on in the book. Where is something with a schematic? This one oh yeah, okay, so here's an example. You can see on this particular schematic that on the negative side, so the ground side essentially, there are quite a few parts that are connected to it, including the ground pin on the 555 timer, these capacitors, the relay, etc. So the benefit, and also for these connections to switches perhaps, this board could benefit much more from having a ground plane because of these common connections. So thinking ahead, what I had in mind is, this one could have a ground plane. I'm not necessarily going to recreate all of these projects. I'm just going to do some of them. Some of them don't make a whole lot of sense anymore in terms of they are dated in their application.
That they make common use of that 1K to 8 ohm speaker transformer, which can be hard to get a hold of.
Yeah, there are some parts that are quite common in these projects that aren't so common anymore. So my inclination, looking at the big picture of doing these projects, is to explicitly route the negative on this project, given that it is only 3 connections and it's very early in the book, and not have a ground pour, like not have a, well, not ground, I mean not have an unconnected pour, so that the top of the PCB is nothing but the traces, and it makes it very easy to physically see where all the connections go and then correlate that to the schematic. And then in a subsequent project, explain what a ground plane is and use that in one of those projects, so that the explanation can show that this is a way of not having to explicitly route this track, but have that signal available all over the board. And it could also explain that in a similar way you could have a ground plane on the front of the board and a power plane on the back of the board, so the positive side could potentially be available everywhere on the other side of the board. But anyway, that's for a future thing. So where this leaves my thoughts at the moment is on this, not having a pour and explicitly routing those signals so that when you look at the PCB, you can trace the circuit in your brain. You can see where it goes.
The idea of introducing what a fill is and why it's so useful, I'm thinking anything that you can push back to a later board and just reduce the cognitive load when they see this first board.
Yeah. Oh, Jack's Tech said shorting to a ground plane as a new solderer is also something to consider. That's true. Much less true with good solder mask, and solder masks these days are pretty good, but you're right that with rework the solder mask can become damaged, and if the copper pour is quite close then you can end up with bridges. I have seen that happen before, so it's not an unheard of situation. Having nothing but the traces on the PCB, I think, is probably the sensible way to do it. David said, wouldn't it make sense to make traces visible on the outside of the board and put the common broad layers such as ground and power in the middle? The user of this board wants to see the traces. Not for this level. For one of the more advanced projects, yes. And the other thing is that this really only needs to be a single layer. It doesn't even need to be a double-sided PCB.
We haven't done the crossover yet.
Yeah, we haven't done this crossover. That is a complication. But for the very first one, my goal is to keep the traces here representing the schematic. Now, there was a comment earlier that I saw and didn't read out because I was going to come back to it. Where is it? Sorry, I can't see where the comment was, but it was about drawing the traces on the PCB. And yes, that is something. In fact, when I did this in Eagle, when I recreated this one in Eagle, I put silkscreen over the tracks so that they would be very explicitly shown. So you could look at the PCB and see the circuit, and reproducing the schematic on the PCB I think is a really interesting idea. Parts of it will be hidden. For example...
Do you mean the schematic or a replication of the tracks?
That's a good clarification to make, because I was talking about both and they're not the same thing. The version that I did previously in Eagle, I represented the tracks. So what I did was I routed the tracks.
Says that Sage should move the traces to the bottom layer then.
I would agree with that, because I think, John, you and I are used to doing surface mount boards, and we put our most important tracks on the top, especially if you've got a chip. All those tracks have got to go into the chip that's on the top layer, but for through-hole boards like this, traditionally the tracks are on the back side. So I can help you switch those tracks.
Okay, very cool. Yes, I agree. So with the traces on the back of the board, it means they are no longer visible from the front. And then if we want to represent where they go,
they're also not obscured by the caps are going to obscure the tracks, for example.
Yeah. So then we could draw the signal on the top using silkscreen, or we could represent the schematic on the top. So we could make it like a stylized schematic with the parts in the positions over the schematic where it matches this. But I think that might be taking things a little bit too far. Maybe, maybe not.
I think it has the potential to confuse more than to help.
Okay. Alright, so what I want to do now, and I don't know how to do this, so I'm going to need some help, is remove this pore. Is it as simple as selecting it like this and hitting delete?
Yep.
Haha, amazing. Backspace. There we go. Okay, so that is removed. And now you can see that the ground signal here, in fact what I'll do is I'm going to come back to the schematic and I'm going to, oops, no, I didn't want that. I've got to break this habit. I'm in the habit of selecting something and then applying a tool to it. I need to just mouse over it and hit delete. It's as easy as that. So now if I wanted to, no, not bill of materials, come back to here and F8, was that what I meant to press to update?
Yep.
Alright, I'm going to zoom in on here and press F8, and that net name has updated. There we go. So it's now BT1 negative and the other one is BT1 positive for the two battery terminals. Okay, we no longer have an explicit ground net, we just have the BT negative that comes along here. Now to move these onto the other side of the PCB, what would the best process be for that? Like to change this from front copper to back copper?
Good question. Let's just review what's in the bottom right hand corner there. We have some presets there.
Ah, right. I might need to move this a bit so that it's visible. Oh no, it is visible there, but I'll...
So we've got some presets there, and then we'll look at the selection filter.
All right,
So if you click on the preset there, the drop down,
got presets, which are all layers, yeah.
it's worth just having a bit of a look here. So it's very common to switch between back layers and front layers.
Yeah. So if I go to all copper layers, it's no longer showing the silk screen or outline of the parts.
Select a trace, hit U twice, hit E.
Thanks, Scott.
Scott Miller said, select a trace, hit U twice, hit E.
We got 2 that time. We didn't get 2 on the previous time. Okay, so back layers we should have nothing except the holes, and front layers we'll have the holes, the copper, and the silk screen and everything else.
By default with KiCAD you'll get some fab layers as well, and I think we deleted those when we first set up the board. I think it's a great idea. So back to all layers.
Yep.
So you've got your presets there in the future. The other thing is that you can click on the little eyeballs on each of the layers there to turn on and off individual layers. For example, you may want to temporarily turn off the silk screen until you get to the point where you work out where the designators go.
Yes.
It can be useful when you're just routing.
Yes, because silk screen is often just visual noise, and when you're trying to make traces fit, it can be good to get all of that out of your field of view so you're not even thinking about the silk screen.
So all the presets does is essentially set those eyeballs for visibility.
Okay, yeah. So these presets are collections of visibility attributes for these layers.
Yep. Yeah. Advanced feature we won't look at, you can also set transparency of particular layers. And colours for particular nets, but that's definite squirrel territory. So, okay, moving on from the presets below that is the selection filter. If we rubber banded the whole board there, we would pick up not only the tracks, but also the components as well. And
yes.
I see John there has done a rubber band from the right-hand side to the left-hand side, which means even if you don't completely cross over something, it will get everything which at least partially got covered. Whereas a drag from the left-hand side, something would have to be completely inside the box in order to be captured. Good demonstration. So if we do a rubber band like that, we're going to pick up everything, but we could go to the selection filter there, and at the moment if you click all items, then it will select everything except for stuff that's locked. So you can very quickly select all or nothing by selecting that box that you just did, and then after selecting nothing you can then just turn on tracks.
Yeah.
And then
so now if I drag across, it'll only select the tracks. Okay.
You can then press E for edit. And then it says FCU for the front copper layer.
Yep.
You'll be able to select a BCU.
For back copper.
Yep.
Yep. And that has just moved them all in one go.
Yep.
Very easy. Now there were a couple of comments as well which might be more relevant for when you're just changing a particular segment of a track. So let's look at that. So Scott says select a trace, hit U twice and hit E. So
let's select that little diagonal there, just the diagonal.
That one there,
yep.
Okay.
And see what happens when you press it once.
So I press
so we've
U
just got
once.
a segment selected there.
Yep, in fact I'll zoom in to make it more obvious. So I'm going to press U once. Okay, that selects the entire, not just that part of the segment, but the entire trace to its endpoints. And then I'll press U again, and it has now extended that selection all the way across for that entire net. Right. And then hit E for edit, and it gives you the option of changing it just as we did before. So we could select the layer that we want it to be there. So effectively, this last part of it is what we did by selecting everything with only tracks in the selection filter. And then E for changing it. Okay, so that is very useful to know. So if I just moused over this, for example, and hit U.
Austins_creations said try U and the F as well.
U and the F as well. Oh, hitting F, okay.
Good point.
So Austin said you can use F when selected to just auto change the layer versus using the menu.
So F stands for flip.
Right. So I've selected just that segment and I do F for flip. Oh, It's
Not
it's
so
mirroring it. Yeah.
much. It is changing the layer.
Oops.
I would file that under unexpected behaviour. I'm not sure what happened there.
No. Have I deleted those tracks? Let's just go to all items so we can see them all.
I select so. I think so because you've got all layers in the
And
preset.
I can't see anything, so I'm going to hit Command Z a couple of times. And it is just going back to there. That's odd. Very odd.
Help us. What happened? Write in with your ideas, with your theories.
Yeah. Well, we still don't have the silkscreen visible.
Let's try presets if that brings it back.
Yeah. Oh, now I've gone back to that point. All right, I'm just going to delete that. I'm going to go to presets. I'm going to go to all copper and then all layers. And we do not have the... Oh, interestingly, it's flipped. Oh, no, that's just because I did undo a whole bunch of times. F for fail, says Scott.
It may have been V rather than
V,
F.
yeah. Austin said, that's weird, I haven't seen it do mirror for that. Normally it doesn't mirror for me either, said Intermittent Tech. Scott said F is good for moving components to the other side of the board, and apparently not for tracks.
We're running 8.0.0 here on the KiCAD Discord. There's an increasing message you see from the developers saying, yeah, we know about that one. There's a fix for it in the 8.0.1 release candidate. Maybe this is one of them. I really don't know what's happened there. It might be a time to hop out without saving.
Yes, I think so.
Eject.
Yes, hit the eject button. All right, I'm going to close that and I'm going to say discard changes. So this, it shouldn't matter about this. This is in an unsaved state, but if I now flip to PCB view, this is partly me exploring what's going to happen in the situation as well, and the potential for things getting out of sync. So as I understand it, now this is one area where in Eagle things could become broken very, very badly. If you had the schematic open, for example, and made changes, or the PCB open and made changes, then when the other one wasn't open...
Scott Miller said one day, I might get around to updating from 6.
Then the two would become out of sync, and you could end up in situations that are very hard to recover from. And from what I've seen of KiCAD, it should be much more resilient. Now they fixed that in Fusion. It won't actually allow you to have the schematic open without the PCB, etc. But in Eagle, that used to be a real problem.
Notification. 1 hour remaining.
So I've now got the...
Let's have a look at the F8 dialog for a moment there.
Yep, so we've got the schematic, which is currently in an unsaved state. I added the ground and took it away again, and it may be slightly out of sync with what is here, because we've got the net there, we've got the ground plane that was added before. So now if I hit F8, as Mitch suggested, we'll see what it's going to do.
Before you click update, as it turns out, it's got those processing messages, and then there's no action to be taken.
Yep.
The option up the top there, relink footprints to schematic symbols based on their reference designators. Usually that's off, and what happens is that every symbol and footprint has a UUID, and that's how the two are logically connected. Sometimes you want to turn this on so that it'll make the association between things in the schematic and things on the board by the designator rather than UUID. So that can be handy for fixing up particular things.
Yes, so that it's saying R8 in the schematic is R8 on the PCB rather than looking at the UUID. Yeah, so in general you'd want that off, I guess.
It can also be very useful, for example, when you've renumbered things on your schematic and yet you want the ordering to still say the same on the PCB. I think initially we had Q2 and Q1 swapped. That would be an example. You could fix it in the schematic and then have them stay in the same place, because use that option. The other thing is it's possible to add footprints onto the circuit board that aren't associated with elements in the schematic. The complication with that is that there's an option there, delete footprints with no symbols, which is if you've decided not to use a certain amount of parts, this option can be very useful. If there's a chip that you're not using, that you've done it another way, this will get rid of the chip. But if you've added things like mounting holes and stuff like that, well, you can, surprise, surprise, lose those mounting holes.
Yes.
What a lot of people do is that they'll put, for things like test points, mounting holes, pins, things like that, that may not even be electrically connected, they'll put symbols for that on the schematic, just so that when this option delete footprints with symbols gets turned on, which is sometimes useful, you won't unexpectedly lose things.
Got it. A good example of that, which this is something I come across in Fusion, is fiducial markers. So what I do is I add a fiducial in the schematic. So even though electrically it means absolutely nothing, it's not connected to anything, there might be 3 fiducial symbols in the schematic, and they are therefore also footprints on the PCB. And if you delete it off the schematic, it deletes it off the PCB. So yeah, this is a situation where you need to keep track of what you might have added to the PCB, and you don't want it deleted. Okay, so normally it would make sense to have the first and second options turned off and the third option turned on, I guess. Or not. Oh, replace footprints with those specified in the schematic. Okay, so that could be off as well. Right. Okay, so replace footprints with those specified in the schematic would be if, for example, in the schematic you had said this is a through-hole resistor lying horizontally and it is 0.6 of an inch long. And then on the PCB you might have changed it to be a surface mount footprint, and then if you have this option turned on, it'll update it to make it the through-hole part. So it'll force it to be in sync. Yeah, because in most situations you would probably want it to be on, because if you are specifying the footprint in the schematic, you would want that information to flow through onto the PCB.
You may not be ready for it yet. That might be why you haven't. You'll turn that off. If this is designed to go in a Jiffy box, we might put mounting holes in the schematic and then have that flow through to the PCB editor.
Right. Okay. Yes. Okay,
I
so
reckon, John,
there's no point doing update PCB because there's nothing to update.
Yep. We kind of backtrack, look at the zone, look at the things that we have to connect since we don't have the zone, flip them to the other side of the board, and then work out what the size of the PCB is going to be.
Okay, that sounds like a good plan of action. So I've selected the zone, I'm deleting that, so now we have an air wire connecting BT1 instead of relying on that zone. And now we can go back to putting these on the other side of the board. So here's the test for myself. I'll see if I can remember how to do it. So I'll turn off all items. I'm going to turn tracks back on the selection filter. Just as an experiment, can I do Command A?
Yep.
Yes, I can do Command A, or I can drag across. Either way does the same thing. Then I'm going to press E for edit, select back copper, hit OK, and now all of those tracks are on the back of the board. Very easy, I like it.
Command 3 will show you that board.
Command 3 will take us to the... Oh, I've got function... Oh no, that wouldn't be it. Command 3?
Not F3, just the number 3.
Yeah. Maybe it's Control 3 on Mac, or Alt 3.
It's in the pull down, so we'll work it out.
Oh, there we go. It's Alt 3. And that shows us the 3D view. Coolio. Now, there was a comment earlier that I didn't read out, which was in relation to a second LED. Once again, I apologize, I can't remember who said it, but someone pointed out that in the PDF there is a reference in here about a second LED, and you can see that there is a link
Scott
on the
Miller
board.
said, don't forget to select BCU before you add more traces.
Don't forget. Ah, right.
I wanted to see what he'd do. Spoiler alert.
Spoiler alert. Okay. So, yeah, you can see that the PCB is symmetrical and it has a spot for a second LED. So you can put a second LED here in the original design. And this is, okay, so I think we should support that. Let's do that. Now in the schematic...
We ain't going to get to Gerbers today.
Probably not.
Maybe we come back to this.
Yeah.
Unless you want to meet, unless you want to meet again next week, which I'm very happy to do.
Scott Miller said, "Sorry, Mitch." Would have been funny.
Scott Miller said, "Sorry, Mitch. Would have been funny."
I kind of like the double up now. It was annoying at first, but now I find it kind of amusing. All right, there are a couple of things. Yes, I would like to get to producing production files, even if they're not final, and I need to generate them again because I want to go back and make changes. So there are a couple of impediments, a couple of things getting in our way so far. One is we were talking about making changes to the footprints of these transistors to make them easier to solder, moving these pads further apart, like spreading them into a triangle shape.
At the moment, with our board settings, that's a clearance violation there.
Yes. You can see the orange oval around that central connection is overlapping the adjacent. So each of these, so I should have checked, this is my assumption, is that this edge here is showing like a keep out area.
Yep.
Right, okay. So there shouldn't be any other signal inside that boundary, and they very clearly overlap there. With the current design rules. The design rules would dictate how close you're allowed to be between differing signals. And at the moment, it's putting this gap in there, which is greater than the spacing between these. So a PCB fab house shouldn't have any trouble actually fabricating this. That gap would be relatively large by modern fabrication standards, but we want to make this as relaxed as possible. Lots of space between the pads, make it easy to solder without giving people a challenge.
I think it's just a recipe for bridges for people who haven't soldered before.
Exactly.
Also, if those pads are bigger, it's going to be more tolerant of somebody putting a lot of heat onto it with a soldering iron.
Yeah. And these tracks that I've been using are huge. Now, on the PDF up in the top right, you can see that the original PCB had these pads spaced out into this triangular shape. And in fact, the PCB has one of the traces passing underneath the transistor. But I think the first thing is editing this footprint so that we space these apart a little bit. So Scott said, need transistor footprint like the old days where you had to bend the pins. Yes, that is exactly the goal. That's what we want to do here.
We want to splay the legs.
Turn it into a tripod. Well, it's kind of a tripod already, but not a very stable one. Alright, so this is the question. Now, in the past, the way I would have done this is gone all the way back to the original library part for this footprint and edited it, possibly making a duplicate of the footprint so that I can have multiple versions of it, because in Eagle and Fusion it's not possible to edit footprints as they exist on the board. But from what I've seen in KiCAD you can do that. Is that correct?
You can, but
not recommended.
Whether or not you should is another matter.
Okay, can and should is two different points. All right, so what would be the approach?
I like the first plan.
Okay, the first plan being edit the library.
That's right.
To make a second footprint.
Clone the existing footprint.
Yep.
And put that into a
Scott Miller
project.
said you can edit local footprints.
Yes, you can, but whether or not you should is another matter. It's too easy to have them blatted by an update that you do later on. Also, we've got two of these here, so do you edit it twice or do you edit once in a library and then have it update?
That's a good point. I would like to learn how to edit the footprint directly, because that sounds like a really useful, very powerful thing to do in in odd
Stop Miller
situations.
said or create a custom footprint in your project folder.
Absolutely.
Yeah.
Resist, John. Solder
yes.
must resist.
And yeah, so Scott said create a custom footprint in your project folder.
Austin, it probably does.
That was in relation to Austin's comment, which was, I'm surprised KiCAD doesn't already have a larger through-hole footprint. Yeah, it may.
Let's bite this 3-terminal bullet here.
Yes. All right, so this particular part, would we go back to
Austin's_creations said Mitch rolling on the floor laughing.
Intermittent said, yeah, normally you edit library unless it's a one-off. Oh, and Graham said, just a minor point, the square pad on the caps and battery connector are on the positive side, but the LED has it on the cathode or negative side. Oh. I hadn't noticed that.
Yeah, it's which pin is which.
True. Yeah, so it's got pin 1 as the cathode.
Possibly because of the flat.
Yes.
So maybe we put on the to-do list that we change the footprint for this one as well.
Yeah.
But meanwhile, let's look at the transistor one.
Yeah.
So what I suggest is to select the transistor and make note of the
Oh, I know why.
Yes.
You weren't pointing it out because you wanted to see how long it would take me.
Yes.
There is no track here, so I can't select it. All right,
I'm messing with sleep-addled John.
I'm going to say all items, and then I can select it, either drag or cross, or... No, that's just selecting the particular pad. Oh, I wonder if I can drag the pad. No, I can't. All right, so I selected the whole transistor.
Yeah, generally I'd click inside the kind of silk screeny area.
Okay,
Yeah,
the bounding box.
Yeah. So make a note. So down the bottom of the screen here, it'll say what this footprint here is here. So make a note of what that footprint is.
That's very small text on the screen, but it says footprint package TO SOT THT TO92 inline.
If you want to paste it, you can probably
that was not what I was trying to do.
Do an E on the component and it'll be in a text line.
Oh, okay. What I was going to do was that.
That's pretty grotty, John.
It just disappeared. Okay. So what would I do? E for edit, and then it will be here, and it says footprint is that, so I can select it and then copy.
It may not actually select it. You may need to click on it so it becomes a text box.
Except that I can't. With this one, I can.
I don't have an
Alexa, stop. And with this one, I can...
Scott Miller said to 92_wide.
92_wide. So there is a suitable one available.
System notification. 45 minutes remaining.
So we've got some options down here. We've got update footprint from library, change footprint, and edit footprint, and edit library footprint. So if I do edit library footprint, now this came from one of the default libraries, which, okay, if I click edit library footprint, will that then edit my local copy, or does it allow me to make a duplicate, like a project-specific copy?
You can do that. There are some warty bits involved there.
Well, based on Scott's comment, change footprint is probably the way to go about this.
If you're asking me, I would do it in the schematic. I would do it in the schematic editor.
Yeah. And
if I was going to do my own footprint, I would do that from within the footprint editor program.
Okay. So if we come back to where is it? Isn't there a project window that shows all the different tools?
Yes.
Yes, but it's not listed under window. It's only got PCB editor and schematic.
You might be able to command tab to it.
Yeah. Command tab. Oh, no. It's going to be... No. I don't know.
Command tilde?
Not sure.
Backtick?
Command backtick. Oh yeah, there it is. Okay. and we've got the footprint editor here.
Yep.
But what I'm going to
Scott
do,
Miller
based
said
on Scott's
double-click the
suggestion,
transistor.
yeah, double click, and what I'm going to do is do change, no, okay, we've got footprint, this is the test of my memory here, so we've got the TO92 inline, and presumably the inline is because the three pins are all in line, and there is the little library icon here. So if I select this, I can probably find the wide version. So we've got TO92 inline and TO92 wide. That looks closer to what we want. So I could just hit OK and update it. And OK.
Yes.
The symbol hasn't changed. But if I now go into the PCB editor, and you can see it hasn't yet changed in here, I'm going to do F8.
You can also do F8 from the schematic editor, it'll do the same thing.
Oh, okay, so you can do a push as well as a pull.
Yep.
So the only change that it's got here is change Q1 footprint, and I'm going to do update PCB, close, and now we can see that this footprint has changed and the other one has not. Now, as a matter of interest, if I select this, so double click to edit, and we've got the footprint set here, if I do a change footprint, I want to basically see this clobbering myself. So I've got change footprint with library ID, footprints with library ID.
That's useful if you want to replace it on the whole board.
Okay. So I'm going to go to TO92. Oh, there's an inline wide as well. That's interesting. It's not the one we want though. We just want the TO92 wide, which is the tripod type thing. So if I change that and apply the change, what happened then? I don't know what happened. All right, E for edit. Oh, it's still set to inline. Change footprint. Mitch is sitting behind me, I'm sure smirking, knowing what I've screwed up.
No, I don't actually. I just wouldn't do it this way.
Okay.
So you ventured into where dragons lie.
Yep.
At your own peril.
Yep. What I was just trying to do is see it fail by making a change TO92 inline, TO92 wide. I wanted to make a change on the PCB. Okay, so I just changed the footprint for both of them. And now if I pull from, where is it? Which is the...
hang on, what's the little cap symbol there?
The little cap symbol,
Yeah.
that one.
Ah, not that one.
Show
I
three
thought maybe
view.
that's why the components disappeared earlier.
Oh, okay.
But
Download
no.
checker? No. Browse, create. Where is the... Oh, I'm just going to do F8 because I can't find the thing. So if I pull this now, it is going to update sheet name to root.
I don't know
Q1.
why it's doing that.
I don't know what it's doing there.
It's
I
possibly
think
a
I'm
bug.
going to back out of this. But what it's saying it's going to do is change Q2 footprint from that to inline.
That option, replace footprints with those specified in the schematic, is where you may turn that off because you want to
because you want to
preserve
retain
something.
it.
And it's too easy to have that on and then lose a custom change that you've done.
Yeah. Okay, so instead what I'm going to do, can I do a shift select to do multiples? I can. Nice, so then I can do E for edit. No, I can't. Can I... no, because they have different attributes and things now, they probably can't be edited together.
Scott Miller said John has found a way to balk it.
Yeah, you can trust me to do that.
Good job, John. I would use the bulk edit tool.
Yeah, this one up here, and we've got Q1 and Q2.
currently says
and
mixed
it says
values.
mixed there for the footprint.
Mm-hmm.
So if I click on the library item here and find
Yes,
TO92
you can,
wide.
but meanwhile, don't. I'll do cancel there.
Okay.
The mixed values there, so Q1 and Q2 is there because we've got value group by turned on.
Mm-hmm.
If you expand it, you can then use it to copy from one to the other.
Okay.
So I would double click on the wide one.
So I can take the wide one,
Copy
that, and paste it into this one.
Yep, or the mixed values field.
Oh yeah, and then it would just apply to all of them.
Yep.
Yeah. Okay. So that no longer says mixed values. And I'm just going to save this. I haven't saved it all. And if I do F8 from here, it's going to change Q2 footprint. So I'm going to do update PCB, close, and now both the footprints are changed.
Here's Johnny.
Hooray!
We have a Johnny Bergdale in the house.
Oh, g'day Johnny. Good after midnight, says Johnny. Oh.
So we've seen how we can go and change something in the schematic and have that flow through to the PCB. We've seen that it is possible to modify it directly into the PCB, but there are kind of gotchas in doing that where you're probably better off modifying it in the schematic. I reckon it's still worth upping the size of those pads a little bit, and that it still might be an opportunity for us to create a local version of this transistor that has expanded pads.
Mm. And the size of those pads seems pretty much the same as the pads on these resistors. So
it's a little smaller.
Perhaps it's worth editing the resistor footprint as well to have nice big pads on those.
And that's how we ended up with fun way versions of the components.
Yes. Okay.
Shall we do that?
Yes, let's do that.
All right, okay. Recommended practice. Well, at least my recommended practice is to do this courtesy of the footprint editor.
Mm-hmm.
So make a note of the footprint. I think we've now got that's TO92 wide.
Yes.
Mm-hmm. Let's go back to the main window. Where's that one? Command tilde.
Yeah, it wouldn't go back to it that time.
It may emerge if we move this window to the side.
Yeah, there might be some strange window management stuff going on. There it is, it's hiding at the back.
So
all right, so footprint editor.
There.
Oop.
Yes.
That one.
Yep.
Okay.
So let's find
TO92 wide.
Yeah.
All right, and how about I just start typing TO92 and see if that narrows it down.
Yep.
Package TO SOT23, and here we have not TO92 wide, not the one that we had selected.
Hyphen.
Ah, yes, TO92. Here we go. So TO92 wide is this one here.
Yep. So we could double click on that and that would bring it in to have a look at that. Mouse over is pretty unhelpful. I think that's been fixed in 801. If you right click on TO92 wide.
Over here in the list?
Yep.
Yeah.
There is a duplicate footprint.
Right.
And I think it's new in KiCAD 8.
Okay, so it's made a TO92 wide _1. Oh yeah, that tooltip is annoying. And if I
because
double
this
click
is in
it,
a system library, you won't be able to save it.
Right, so I need to save this out to I need to create a new library.
That's right. It can be done from back at the main screen where you do maintaining your projects, maintaining your footprints and symbol libraries. I think you can also do it by, let's look at the save option under the file menu.
Okay, now Scott just said, I generally create a folder inside each project named KiCAD Customs that contains a 3D folder, a tinker.pretty folder, and a symbols folder.
Yeah, I did the same. I call it local, and it's got local symbols, local footprints in it.
Yep. Graham pointed out, be careful with the Q1 and Q2 footprints losing the important symmetry implied from the schematic. All right, interesting.
We'll keep that in mind.
Yes.
Let's have a look at the save dialog.
Yep, so file, save, and save as.
Because let's look at new library there.
New library. Okay. Global and project.
Yep.
So I'd make a project library.
Mm-hmm.
Now, before I do, there are going to be multiple projects in this family of projects.
Yep.
So there's going to be project 2, which will presumably have the same resistor footprints.
Yep.
Can we create a project library and then still access those symbols from the other projects?
Yes.
Very good. So I'll hit OK. And I will save this. So we've got Funway.
Well, let's do this on another screen.
Okay. This is all open source stuff, but
Okay.
yeah, we'll move it to another screen temporarily, just while we get our location set. Yeah, that list of folders in that directory is Superhouse projects, and all of those are open source or something anyway. So I don't mind.
Don't
that.
even try, people.
I don't mind that list being public. All right, so there's already a folder here called KiCAD library, and it has a funway.kicad_sim in it.
Yeah.
I'm not sure where this came from. Was this from a previous experiment?
Could be.
I don't remember.
The viewers can't see this, by the way.
No. Okay, let's bring it up here so everybody can see. So we've got FW2 Project 1. This is our current project that we're messing around with. There is this other folder called KiCAD library, which has Funway KiCAD sim in it. Let's ignore that for now and create a new folder or something to put this in.
This has activated my curiosity. I'm tempted to escape out of this and go and have a look at what projects have already been added to this project. Sorry, what libraries have been added to this project. So I would hop out of this. I would hop out of the footprint editor as well.
Yep.
It'll say, do you want to save?
And I'll say no.
So there's a preferences pull down there.
Yes.
Top and manage symbol libraries.
Mm-hmm. And I'll bring this up on the
So
screen.
we've got a global libraries tab there, and I'm wondering what we're going to see if we click on project specific. And that must be one we added, I think, in the very first week.
Possibly.
Remember that?
I don't remember the first week.
Neither do I. Carefully repressed memories.
Yes.
But this may be where we park things like custom transistor and resistor symbols. And then when we do an update from library, if we go into a particular project,
Imogen Ann set it outside the box.
then that'll pull in that change that got made. All right, great.
Yep.
So we know this is here. I would go back into the footprint editor, load up our little footprint.
Okay. I'm just curious to... So this is wide_1. So it has created this. I closed it and then opened it. Is it just because I didn't quit out of KiCAD entirely that it's remembered this?
Outside the box says dodgy. Hiya.
We needed
Hiya,
that.
dodgy.
We needed that in a say, didn't we?
Yes.
I use Linux,
System notification.
and these
30 minutes
system
remaining.
symbols and footprints would be installed not using my username, so I wouldn't be able to write to it. It's possible that these have been installed on your system, and you can write to it, and that's why it lets you.
Yes. Yes, that is quite likely. It'll be installed at a user level instead of at a system level.
That's it.
So,
So
maybe I want to delete this one just to clean up after myself. So if I have a look for a TO92, you can see that TO92 wide 1 is here.
Yeah.
Even though I have it open, I'm going to try delete. Can I delete the footprint?
Yes.
Delete footprint from library. Here we go. Delete it. Yes. Okay. It's not showing this library as being in an unsaved state, which is interesting.
Yeah, that's because you don't have anything there unsaved. It made that change live to the library. It really just went and deleted a file.
Okay. Oh.
Let's clear out the little search filter there and see if we can find that library that...
Yeah, it was Funway... Where are we? See if it's in the list. It does not appear to be in the list.
is it right up the top? Because we may have... No?
No. Funway. So it doesn't know about that particular library.
That's a bit odd.
Hmm.
Be there somewhere.
Hmm.
It's called. Let's check under K.
K.
I scroll down to library starting with K.
Oh, I'm
Because
gonna-
I think it might have been called KiCAD library.
Oh, yes, I think you're right. There are no K libraries.
Well, I'm baffled. Let's.
It exists on disk and it's not associated with anything.
I reckon we do a new library and kind of press on.
Oh, could that have been because it was created with KiCAD 7 and we're now on 8, and 8 does not necessarily know the path to libraries that were referenced previously?
Yes, it could well.
Yeah.
I reckon we press on.
Yep.
We look under the file menu and we go new library.
Okay. New library, project specific, and we have this old KiCAD library thing, but
Miller
let's
said try unnamed.
try unnamed.
Yep,
Oh.
worth a try.
Okay, I'm going to cancel out of this because I want to see that. U for unnamed. There is no U here. Uppercase, just in case it sorts lowercase at the top. No, it doesn't.
I seem to remember we also did the pin library, so it stayed up the top, but it just doesn't seem to be there.
No, I think it might be because it hasn't carried over from KiCAD 7. It's started with all new preferences.
Let's try
Right.
add library and see if we can pick it up in the file dialog.
Oh, yes. Project and that's project 1. I'll back out of that and go into KiCAD library, select that. Oh, it won't let me select it.
Yes, because you're selecting the directory.
Oh,
So just
okay.
open here.
Select that
Go
and
in,
then open.
go into there.
Ah,
So this is a directory selector rather than a file selector.
okay.
Great.
And now we have KiCAD library down the bottom. That is a terrible name
Yeah, it is, John.
with nothing in it.
If you right click on it,
Yeah.
we can do pin library. It'll move it up to the top there.
Mhm.
It's really convenient.
Yeah. And then I should rename it to something like Funway Library.
Yes.
Can I double click it to rename? No.
Yeah, or you can.
It's on disk, I guess.
We are descending down. Look,
Well, yes.
believe it or not, this aspect of KiCAD library management was far worse in the beginning. This is much better than it ever was, but it's still just a bit grotty.
Mm-hmm.
I reckon we come back and fix this up
Yeah.
later.
Yeah. So
What
how about
what I would do is go to the
I
transistor library the transistor symbol that we had, and do a copy, and then we paste
Scott
into
Miller
that
said
library.
bork.
Yes. Put the chicken in the pot. Pork, pork, pork. There we are.
Alright.
I'm speaking Johnny Bergdahl.
All right. So I won't rename it for now. That's a problem we can put off until later.
Yep. Let's find that transistor.
So I'm going to
So-
find that TO92 wide.
You and I are both in pain, John,
Yes.
but we're pushing
For
through
different
people.
reasons. All right. So
Things we
this
do
one.
for the clicks. So if you right click on that,
Yeah.
there's a copy.
So I want to copy the footprint,
Mm-hmm.
and then I can go out of here and into the other library
Yep.
and paste.
Yep.
All right. So into here
Yep.
and paste footprint.
Yep.
Library not found. Does not exist. There is something odd going on there.
801, you reckon? So let's do a yes. We'll push through. Maybe
Yeah.
we can get it to crash.
Yeah,
And it was hilarious, wasn't it?
it was.
Oh, okay. All right. Great.
Okay.
Let's make our changes here and
Save it.
get out
and
of
apply.
Dodge.
Yes.
Yep. All right. So click on a pad.
Yep.
There is also a. You look at the window title there. It says KiCAD Library TO92 Wide Footprint Editor.
Yes.
Just below the word KiCAD, there's an orange icon there.
Right.
And that's essentially your bulk edit for pads.
Mm-hmm.
Very useful for setting what type pins are.
Okay. So here we've got.
Maybe this is our defaults.
Mm-hmm.
Maybe this would be useful. We just up the diameter here.
Pad shape circular, diameter 1.54 millimeters. That is probably a reasonable hole size, but what we want is a bigger annular ring.
So the hole size is 0.76.
Ah, here we go, 0.7. Maybe that could be bigger, like it could be 1 millimeter or so.
I think if you make it too big, the transistor's going to rattle.
Oh, this is for the transistor, yes,
So
which
I'm-
they do have very small pins. So 0.762 is fine
Miller
for that.
said with the footprint open in the editor. Save as.
Yes,
Yep, we will.
we will. It assumes, Scott, it assumes that the library exists.
Yeah, so here we got, okay, so that's the hole diameter, and this is the annular ring diameter. So if I make that bigger,
2.
say, yeah, I was going to say like 2.5 or something. No,
Wow.
2.5 probably won't fit because this is the transistor. Yes, let's just make it 2 and hit OK. It may not change this because that would have changed, as you were saying before, possibly just the default.
Yeah.
So what we want to do
There
is...
is a, let's look at the mouse overs along the top there. There is a bulk edit for pins.
Footprint checker window, edit footprint properties.
No? No.
Can't see it there.
Thought there was one. Might be under tools.
So if I'm
Let's go manual.
going to try, oops, not that.
If you select on the pads, it's assuming that you've only got pads selected. Let's do it on the 2 round ones. So select
Yeah,
on
so
that
they
one,
don't have any properties that are
Yeah.
not common.
and then you right click on it, and I think there is a give me what the defaults are.
To like update to the
Yes.
defaults, inherit from the defaults.
There we are. There we are.
Paste default pad properties to selected.
Yep.
Right. And if I did that on this one, it would
think-
make it go round
I think-
instead of square.
Yep.
Which I don't actually have a problem with in this situation because of the silk screen showing the orientation of the pad. But what do you think? Should we just go for a round or keep it square?
I think it's whether or not you want to preserve the basic principle that every footprint is going to have a pin 1, and that we mark pin 1 for orientation.
Okay. Well, let's retain that principle.
I was going to say let's make it circular because orientation here is so obvious. From,
Okay. Yeah. So yeah, I don't mind losing it, but if I do paste default pad properties to selected, that will update it. Okay. Now, getting back to that save as, so we wanted to do file save as instead of just save.
we can just do save now.
Yeah, so we've got save because we are inside this library.
Save as may ask you to choose the library that you want to put it into, but I think we come back and look at that another time. So
Yep.
we've got our extended pads. If we were really finessing this, we may want to change the arc sizes because our pads have grown, but I think that'll be good enough.
Yeah, so what Mitch is referring to here is the lines here that are joining, that are showing the outline of the actual part. But we haven't protruded into the silkscreen area yet by making the pads 2 millimeters. So I think that's okay. All right,
Let's ship it, John. Let's close this one out.
let's ship it. So that is now saved into that library. And if I come back into the schematic,
Yep.
I'm just going to select.
I
I could go into the bulk edit. All right, bulk edit.
Yep.
I like spreadsheets.
Yep.
So now what we can do is change this
Yep.
by selecting a different library entry.
Yep.
And will it be at the top? Yes, it
Yes.
is because it's starred. And we can now select wide, hit OK,
Yep.
and OK.
Sometimes if you haven't changed the name of the footprint, but you have changed the name of the library, it's just easier to manually type in the name of the library.
Okay, yep,
But all good.
good point. All right, so now if I F8 this and push it, I'm just going to bring this back up to make it visible. So this is what the footprints currently look like. You can see that there is a fair bit of space between the annular ring and the edge. I'm going to do update PCB, and they all just got bigger.
We don't know that, John. F2 could be lurking and laughing at us. No, it's all good. They've both been updated. Yippee.
They have, yes.
Great. Sweet. We can see impossible. It would be possible to do that with the resistors and whatever other components we wanted to do.
Yeah.
But that will have to wait for introduction to KiCAD 10.
Yeah.
All right. My proposal is that we route some tracks, and then do you want to whistle stop generate some Gerbers today, or do it next week, or?
I would like to generate them today, even though they are not going to be the final Gerbers, because I will also want to edit the
John,
board dimensions.
There's never a final edition.
No, there's never
only
a final.
Latest edition.
Yeah, there is a latest _ for real _ V2 _ today. Yeah.
No, really.
_ no really.
Hi, Mom.
Because yeah, I want to make these other pads bigger. I'll probably want to change the size of the capacitors. We need to set the dimensions of the PCB.
We need to verify that these part sizes are right.
We need to verify. We need to put silkscreen on. There is a.
There's no squirrel on the board, John. There's no squirrel logo.
We got to have a squirrel. So there is a lot to do, but I want to just, as it is, generate Gerbers to see what that process is like, even though we're going to redo it later. So I think I want to edit the track. Now, was it Scott earlier that was warning about me putting things on the wrong side of the board? At the moment, front copper is selected. And if I route, now I've got to try to remember what the thing is. So if I
Scott Miller said you still need to round the PCB corners.
Totally.
yes,
Austin's _ creations said that Scott Miller has a Steve silkscreen library.
oh, that could be very useful.
Nice. And we can fix Steve's ears, which should point forward instead of pointing up. Just saying.
Now so I'm going to change
put in
to
a pull request. So yes, so you can click on the layer there. You can also, if you're not actually laying down a track, if you press V, it will switch. So let's try that.
So V is switch between the two layers. And if, for example, this was a 4-layer board, would it simply step through those?
No.
4? No, it just flips between front and back.
There is a hotkey. Somebody will. I haven't done many 4-layer boards. There is a hotkey that will do the inner layers. It might be page up and page down.
Okay. All right. Now, is this R for route, T for track? I can't remember. It'll be something mnemonic.
T for tango.
T for tango. And
you'll never guess. Good tools should be discoverable.
They should be. I am going to do no, R was rotate, so I'm going to undo that.
R for hilarious.
R for hilarious. I'm going to try T for track. No.
Folks, we've got 24 more letters to try.
C for copper? I don't know. All right, I'm going to go and find out. Place is draw line. No, not draw line.
I can't actually see it there.
Shift Command L for line. Where is...
Oh, maybe it's the next menu across.
Oh, route. Okay. X for route.
Yes.
Oh, yeah, that makes so much sense.
Never guess. We could have gone through the whole alphabet and...
System notification.
Oh, and then I'm back on the wrong side of the board again, so I'm going to do V to switch it. X for route from there to there.
Folks, we placed our first track.
Yay.
For today.
Second track. Now, this one is going to come underneath. I'm just looking at this bridge arrangement. How are we going to do this? Oh, and this one, of course, has to come under here somewhere.
Nice.
This one is obvious. That one and that one. So, how are we going to solve this particular problem?
It's 2024. We use VS and get on with life. We're not out there with the Dalo pen and the ferric chloride.
Oh, but I want it all on the same side of the board. If I put it on the front of the PCB, of course, it's easy. So the simple solution is to, I was reflexively using right-click to change the bend angle.
The poise, the stance, you can do that with slash.
Slash, okay. All right. And then what I do is V to come up to the top of the board. I would grab this one here. I'm going to do slash to change that, and
you could also go
that.
between the collector and the emitter.
I could. because now we have a nice wide
So what
thing
happens
here.
if you relay that track between the collector and go between the collector and the emitter? So start from the base.
All right, oh, if you relay it, so
Yes.
leave this one in place?
Yes.
So a loop removal type thing. All right, so if I go over that and press X, click on here, come up here and bring it up. Oh, look at that, it's magic. Oh, cool. Now, I just wanted to remind myself, I'm going to get out of that tool. Now, to select that is U.
You can select it by clicking, but you will extend the selection.
Yes, that's what I was just trying to get into my head, because earlier when we were messing around with the track up there and changing layers, so I'm trying to embed these things into my brain. So if I select U, it selects the entire trace.
Here's another thing you'll use a lot. Right click on that segment there and choose break track.
Break. Where is...
Might not be doing that because...
Oh, because I've got the whole thing selected. So
Yeah.
if I just select that one and do break track.
Yep.
Oh, and it's got drag 45 mode, drag free angle, fillet. It's got some other useful things here as well. But break track.
If on the very left hand side, third icon from the bottom there. Yep. If you click that.
Now we can see that there is a break. So this is two distinct segments. I can select that segment
Yep.
or that segment.
And drag them separately.
Yeah.
So
Ooh, I can do that. Cool. Oh, and now because I aligned it, it healed the track and turned it back into a single track again.
Yep.
Okay, groovy. So if I'm going to do that again, go break track and stay in this mode. Oh, if I select that.
I would press D. Just mouse over and D.
Okay.
Sometimes
for
it
drag.
goes pointy there and it's a bit annoying.
All right, so I'm going to come back. Oh, what is it? X for route. I'm going to go from there and relink it there. So now at least if you have X-ray vision, it looks a lot more like the schematic with these tracks crossing over each other. Okay.
Is that where we leave it for now? In
I think it is.
I mean, look, there's so many ways that we can enhance this.
Oh, for sure.
Yeah.
But we're at the point now where electrically this would probably work. So let's just generate production files.
Do you want to have a quick look at the
DRC?
DRC?
Yeah, let's DR the C.
For laughs, I don't think we should spend a lot of time fixing it.
All right, bring this up here and run DRC. And
Yippee!
ignored tests there, but no violations, no unconnected items. Everything
Ship
was
it.
good.
It compiled,
It's
John.
perfect.
Ship it.
It's perfect.
My perfect baby.
Oh, Stephen pointed out, if you don't use a fill, you'll be able to see the tracks from either side of the board. Yes, if there's no silkscreen. It's harder with a silkscreen to see through a PCB. If it was just fiberglass, then yes.
Yeah. Gerber's time.
Gerber's time. All right.
So historically, the file format used for drills is different to what's for tracks. So drills is Exelon format, tracks is Gerber format. This is a little bit reflected in the process we're about to do, in that there's not one button that generates everything. Typically, people will have a directory that they put the Gerbers and the Exelon files into, and that they will then zip those up. I call it output, but other people call it fab. I think you do the same thing when you're in Fusion 360. There's a subdirectory that you put your generated things into. So whatever you want to call it. Let's have a look at that now. So have a look under the file menu.
So I'm into file.
Yep. And fabrication outputs.
Fabrication outputs. Okay, so we got Gerbers and drill files as two distinct things. Oops, I clicked something that was unintentional.
So there's actually three ways to bring up this dialog. One of them is what you did. The other is go into Gerbers, and then you can get drill files from there.
Okay.
And there's also I may have changed it. There was a second option there that did exactly the same thing.
Ooh, Austin just pointed out PCB way offers clear, but it is dollars.
XE.
Clear, that would look awesome.
All right, moving right along.
Yes.
Okay, so let's do our Gerbers there.
Okay. So we've got layers that we can include. We're not going to include adhesive on this, so we've got paste, which there shouldn't be any for these footprints. Front mask and back mask. So there might be situations where, for example, you want to produce a board and exclude silkscreen from one side or the other, so we can just turn on or off what we want to include.
Backmasking is how you do the satanic lyrics.
Oh, yes. Yeah.
Number 9. Moving right along. All right, meanwhile,
Okay.
John and I are now sleep-addled.
I'm losing the
state.
plot.
Anyone would think we had a barbecue or something.
Yeah.
All right, okay, so, all right, we've got our
Scott Miller said the defaults work for JLC or PCB way.
So we've got our include layers there. The plot on all layers is if you wanted something to be, if you wanted to produce a Gerber file that had several layers combined into one. So generally you leave that off, but some fabrication companies will want that border to be on it. This is how you would turn that border to be on in your Gerber for each layer. There's a plot drawing sheet.
Oh,
Option
okay.
there.
So we don't want that.
Yeah.
And Austin said turn off generate, hang on, where was it? Turn off plot footprint text. This one here. So do we want
I
that
don't
off?
know. We're going to be reviewing the Gerbers anyway.
Yeah, okay. So
There's a whole bunch
leave-
of options here which are worth coming back and looking to. Traditionally, there wasn't information inside the Gerber files that said what each file was for, and so we used extensions in order to show that, and that's the option use Protel file name extensions. We have an option there to use extended X2 format where what layer a Gerber file is for is inside the file. So these days most manufacturers, and that includes JLC, I don't know about PCB way, understand X2, so you can turn, as long as you have X2 turned on, then you can turn off the Protel one and they'll all be called .gbr. If you turn that on, you'll get GTO, GBS,
yeah, GTL,
Yep.
etc. Right. Is there any particular downside to having them both turned on?
No.
Okay. If you do not have this turned on, it generates separate files for each of the layers, I guess.
It'll do that anyway.
And what naming convention will it use?
You'll see.
All right. My inclination is to leave them both turned on, just so that you can glance at the files and know which is which.
Yep.
But I'm going to leave this turned off and see what happens with just the X2 format.
Yep.
Okay. Everything else is left default. I haven't changed
There's a
anything.
tenting setting there, but we'll come
tenting.
back to it another day.
Right, okay. Tent buyers is turned on, so we will leave that. We don't even have any buyers, so it's irrelevant on this particular one. So we've got generate draw files and plot.
Yes.
So
System notification.
Let's click on
5
plot.
minutes remaining.
So click on plot.
Yep.
And it's told us it's done a bunch of stuff. It says there is a warning.
There's a field up the top, output directory. That's where you would set that directory. So it's gone and thrown them into where the schematic and PCB is. That we can fix up in post.
Yes. Okay.
And once we've done plot and it generated the Gerber files, we can click on generate drill files.
All right.
And that will give you the same option that you got from the pull-down menu.
Yep. So we've got Exelon options for mirroring axes and various things, and file format can be Gerber
for the map.
For the map file format.
Yep. You can also, in most places, generate your drill files as Gerber X2 instead of Exelon. Generally, slots, for example, that Eagle always had such problems with, plated slots, isn't a problem here. There is two ways to do slots, and the factories generally will do both. The defaults here will be fine.
Okay. Austin said JLC like alternative drill mode. that's this option here. So it's either use route command recommended or use alternate drill mode.
So it's talking about slots, oval.
Oh, yes, okay, so this is for oval holes drill mode, right, which we don't have in this particular thing anyway. But Austin, thanks for pointing that out. So now, can I just do generate drill file?
Yep, so you've got your plated and non-plated there. The non-plated will of course be empty.
Yep.
If we had mounting holes, that would contain your mounting holes in the so folks, the PDH is plated through hole, NPDH is non-plated through hole. Your mounting holes will be in non-plated through holes. The holes for your components will be plated through holes.
Mm-hmm.
Thanks, Austin.
Austin just provided a link.
Let's keep going.
Yep. I'm just clicking on that link because otherwise I will lose it and not have it later.
How to generate, for the folks playing at home, the link that just came out is how to generate Gerber and drill files in KiCAD 7.
This one.
Yeah.
All right. Now we've generated the drill files, we've generated the Gerbers, so I should be able to just close this.
Yep. And then we can open Finder.
All right, and close that. And I can come into the project directory. I thought I had it open.
There's a hotkey for opening Finder.
Yeah, also I've got a thing on here. I can just go projects.
Yep. Hey.
And then into Funway. And because Mac OS is stupid, and anytime you hit enter with a folder selected, it wants you to rename it. I have a thing that overrides that. Oh look, we got
But
KiCAD
it's
library.
intuitive.
KiCAD
Sorry,
library.
triggered.
So in Funway 2, okay, we now have a whole bunch of stuff.
What I would do is sort these by timestamp, so that you can then select the ones that were just generated then.
Yep. And maybe make a folder, and I'm just going to call it Gerbers as a place to put them. And then I can select that one down to there.
Sweet.
Should all be all created at 11:55.
Yep.
Drag them into Gerbers. And now we have our Gerbers all in one place.
We
and
can
the drill
answer your
files.
question of how things are named.
Okay, so it's got B copper, B mask, B paste, etc. So that all makes sense. Job, silkscreen paste.
Job file, the PC factories won't do anything with a job file. It's just, I mean, you can turn it off and it's fine.
Okay.
What I'd recommend now is to go back to the main KiCAD window and activate the Gerber viewer.
All right. Main KiCAD window being this one here, and Gerber viewer. Preview Gerber files. All right.
And then have a look under File.
Just trying to bring this window in a bit. There we go. File, open,
Auto
detected.
Do a shift click to select basically everything that's in there apart from the Gerber job file.
Okay, that one there. So,
Maybe Command A.
yeah, I tried Command A and it didn't work. Maybe Control A? Nope. How about...
It's a Mac.
Yeah, that's weird. How about I do that and then get rid of the job file, like that.
Sweet.
Okay, open.
Yep.
All right. So we have a few
System
different things on the right.
notification. Stream is over.
Okay, what I would do at this stage, something's not quite working okay. I would right click on all those files that are there.
On all of them.
Yeah, just right click there and sort layers if X2 mode.
Okay.
Because then you have your bottom layer stuff down the bottom
on
and
the
your
bottom.
top layer stuff up the top.
Right.
And we could quickly turn them all off and then review from the top to bottom what we've got.
Yeah.
I wish there was a turn them all
Select
off
all, but
hotkey.
there is not.
Uh-huh.
All right, so we've got here just the drill file. So this is PTH drills. If I select it, does it become visible? No. Edge cut, so this is the outline of the PCB. Paste has nothing. Silkscreen on the front is silkscreen, obviously.
Great.
We've got the mask layer here. So this is for a solder mask to keep the solder mask off the pads, which is good. Then we've got the copper, and so
That's
as
front side copper.
yeah, so as Mitch was saying, we're essentially descending through the board here, starting from the front surface apart from the drill and edge cuts, which are kind of
Not
they
planar.
transcend the dimensions. They're non-planar, yeah. So we got the paste on the front, then we got the silk screen, then the mask, then the copper, and then the next one is going to be the back copper, which is this one, and then below that we have the back mask. So this is excluding the solder mask from the pads, and then we have the back silk screen, which has nothing,
Not even a squirrel.
and paste on the back, which has nothing. So some of these layers are empty.
Holes are multi-dimensional, but not hyper-intelligent.
No, not today.
No.
Very cool.
A bit of a poor choice of colour there, that the copper is the same colour as the silk screen.
Yes, it is rather.
I haven't seen that before. But you get the idea. These Gerbers look like they could fly.
They do.
So I reckon we produce a zip file,
Mm-hmm.
and then we,
So I'll close this.
for laughs, upload it to JLC and look at their preview.
Ah, good idea. All right, so that will be in here, inside Gerbers. So what I could do is select them all, compress.
They will ignore the Gerber job file.
Yep. Oh, okay, so it doesn't matter if it's included.
Correct.
All right, I'm just going to call it FineWay 2 P1, and
I would put a version number in it,
yep,
like 0.1.
yep. So I'm just pulling up JLC right here. Sign in,
You
sign
probably
in.
won't need to. You can still do your preview.
I
until
still
you
do the
pay.
upload. Yeah, that's true. V, is it? Oh, V 0. I normally do an underscore for that, but 0, 1. Yep. Zip. And to here, I want to do order now. Order now.
I think you just go ahead, Gerber file.
Yep. Add Gerber file. I should be able to just drag it on, I think.
And then
Uploading.
and then a miracle occurs.
Yeah, quite miraculous.
And we do a Funway Teflon board.
And we've got a preview, and the preview actually looks like it makes sense.
Yippee!
Hooray!
High five.
High five! Yes. We got to production files in 8 brief hours.
Some of them were longer than 2 hours, John.
Yes. Okay. Well, folks, we got there. It's definitely not polished, it's not final, but we got to the point where we can produce these
Miller
boards.
said, don't accidentally order 1,000.
Yeah, I'm going to not even save to cart. In fact, I'm not even going to keep that open. Whew,
I know it's going to
I'm exhausted.
fall asleep at the barbecue.
Yes.
So if you see his face is grilled next week, it's because
Yeah.
yes, when your face
Face
flops into the
down the
dog
middle.
food bowl.
Okay. So there are some things to do way back at the schematic stage as well, such as adding another LED over here, because I want there to be 2 LEDs optionally in this
You'd
project.
have to change the resistor value to compensate, wouldn't you?
Yeah.
Hey John, I've got 2 questions for you.
Yes.
The first is
System
specifically
notification. Peter is hangry. 5 minutes ago.
the first is what still needs doing for this particular board, and we've talked about a whole bunch of options there. I think it's out of scope for today. The second is, as far as you being able to use KiCAD as your daily driver, how do you think that process is going for you?
There are definitely going to be frustrations along the way, and many moments where I will be trying to figure out what is the shortcut for routing a track. X, of course, it's so obvious, but those sorts of things will just be, little hiccups along the way. They'll come and go. I'll figure that out. After I've done it a few times, I'm not even going to think about it. X is going to be routing a track.
X is
It's
right in the middle of the screen for you,
it's-
John. It's staring at you in the face.
Yeah, it's right there. Yes, it's right here.
That's where the treasure is, John.
Not just spot.
So I think this is going to be quite usable. There are things I'm going to have to figure out which we haven't really sorted yet with this board in relation to things like origins. Now there is also, what we're looking at here is
Something
a
about
board.
oranges.
Oranges, yeah. This is designed for hand assembly. When it comes to doing a board, a more typical board that I would produce with lots of surface mount parts, there is going to be a teething stage to go through where things like the rotation of the footprint on the board and what it considers to be a zero rotation may not match what I have been using previously in Fusion, which means that by the time that flows through the entire sequence of generating the placement file and then taking the placement file into OpenPNP and having it apply its coordinate transformation and then mapping that onto the rotation in the feeder, because the feeder might be at 90 degrees relative to that position, my expectation is that the first board I produce using this, I'm probably going to have parts put down 90 degrees rotated and LEDs backwards and all of those sorts of things. That is an inevitable part of the process, and then as those issues arise, I will basically whack that mole and put it back down in its hole, and then I'll find the next thing to fix. But after fixing a few little things like that and making sure that the coordinate systems all match, that's not something that I ever have to think about again. And
for the folks at home, if you use JLC to do your assembly, their databases are notoriously unreliable as far as orientation goes. You really need to take the files that they give back to you and check orientation very carefully.
Mm-hmm. Yeah. And because I'm the bunny that's going to be running the pick and place machine, or more likely my son Tom is, I'm going to have to figure all of that stuff out. So with Fusion, because I have known footprints and all of the coordinate system matches all the way through the workflow, I can confidently put parts down and know that when the pick and place machine puts that part down, the orientation is going to be correct.
Yeah.
I don't have that yet. So what I envisage is over the next probably month or two, as I start using KiCAD for projects and producing boards and then discovering these issues, I'll just have to sort those out. But then getting past those sorts of hurdles, I think this should be quite smooth and fine. I don't see any big problems.
It might be too early to tell. Are you pining for a particular thing in that Fusion 360 has? Maybe the CAD integration, I think.
The CAD integration is a big one.
Yep.
The really nice thing about the 3D viewer so if we switch back to the PCB here, so if we go to 3D viewer, is there a shortcut for it?
Yeah, Command 3.
Command 3. I think it might have ended up being Control 3 on Mac. Or was it Command 3? No, Alt 3.
Mash all the 3.
It's Alt 3. Okay, Alt 3 on a Mac. Having this, to some extent, removes the need for 3D integration, because one of the benefits of 3D integration is being able to visualize your board, which in itself is hugely beneficial for sorting out silkscreen and just making sure things are sensible and you don't have switches overlapping connectors, crazy things like that. The next benefit of the integration is when you want your physical geometry of a PCB in your CAD software so that you can then design an enclosure or make it fit within an existing enclosure. So the 3D view that we have here, it basically takes care of that first use case, and it takes care of it faster and more smoothly than Fusion. With Fusion, it's more of a sync process. With this, it's just open the 3D view and it's right there. And it's got the live update as we saw previously, messing around with this.
The default is that if you move the cursor from your PCB design window over the 3D window, then an update will occur. You
Scott
can also
Miller said 3D viewer also helps you notice those pointy corners.
Yes.
That's Scott Miller's pointed comment.
Select edge, apply fillet. But that is actually an interesting point, because in Fusion, the mechanical tools in the PCB editing part of it are amazing. So you can literally do things like apply fillets to PCBs by selecting a vertex. It inherits all of the super powerful 3D CAD that Fusion already has. So there are little limitations like that. But sorry, you were saying something about the...
Yeah,
3D
so
view?
the default is that you need a mouse over to get the 3D to update, but there is an option you can turn on where it's live. So you change it in one and it will just automatically update in the other. I usually have them with a lovely wide monitor like John's got here. You could have the schematic open on the left, you could have the 3D on the right, and the board in the middle. Really just at the fingertips of your eyes,
Yep.
so to speak.
Pancake Legend is here, Andrew. Good to see you in the chat. Pancake said, I refuse to use KiCAD to create board shapes. I generate edge cuts using other tools.
Yep.
Yeah, I'm not really surprised. For those of you who don't know, Pancake Legend is a CAD genius. Yes, he does some really cool mechanical CAD sort of stuff and creates things with very... Yeah, I won't get into it. But anyway.
One day, if FreeCAD progresses, if the on-cell thing really catches on and they fix a lot of the usability stuff, there's a plugin for FreeCAD called KiCAD Step Up that lets you do two-way data transfer between FreeCAD and KiCAD. Very useful for things like importing custom board shapes, like Pancake Legend is talking about. You can also take PCBs with the 3D models, import that back into the 3D, do things like enclosure design. It's also very useful. You look at footprints and board recommended pad sizes and things like that in data sheets can be a real pain to import into a system if you don't have some sort of parametric modeling. So design the footprint in I've designed the footprint in KiCAD because you can specify distances between things and have changes flow through, and then you can generate the footprint for that and then pull it into KiCAD. Wagon loads, have a look at KiCAD Step Up.
Yeah, and Pancake said, I like tight integration with mechanical and electrical. Yes,
Yep.
That is one of the big selling points now with Fusion. Now that Eagle is no more and Fusion takes care of all of your CAD needs. But yeah, I'm liking this so far. John said, so how soon will Superhouse be accepting orders for small production runs of a few thousand?
Send Bitcoin.
Yeah, Bitcoin. And okay, I do need to wrap this up because it's now 12:15 and I need to start getting stuff ready for the barbecue. But one final thing, some call it fun, asked, do rounded corners cost more money? And Austin replied no, which technically is correct, but it is something that is worth thinking about and understanding a little bit more about the difference. The thing is that if you there is a difference between...
This is more money at the fab house?
I think that's what the question was about. So this gets into issues of things like panelization and full board routing, and by routing in the CNC machining sense. And one of the options when you order these PCBs, I closed the JLC window unfortunately, but there are options to specify if you want your PCBs fully routed, which means that they have cut the outer edge with a CNC machine, and it gives you a nice clean edge
System
all the way
notification.
around.
Peter is super hangout.
But
15 minutes ago.
But it does mean that you get all of your boards as separate boards. So you will basically end up with a pack with however many boards you ordered, all just as loose separate boards, and you get nice edges on them. If you want to have the board panelized, then they will arrive with V-scoring or V-grooving, where they have been partially cut through and you need to snap the individual PCBs apart. And in that situation you end up with rough edges on them. And then in that situation also, doing rounded edges means that the boards need to be set up with little spaces between them.
During the stream.
Peter needs to snack during the stream. Yes, he does. I need to snack during the stream.
We need to sleep.
Yeah.
John.
So that's anyway, that's a whole other thing. Maybe we'll talk about that in a future. Oh yeah, the paper cutter didn't fire.
It never came out.
Yeah.
It actually stopped printing mid-line.
Yeah. Very odd. Something weird going on with that Raspberry Pi. Anyway. Yeah, another day. Okay, I'm gonna stop and collapse, which means I'm just going to sit here in my chair because I'm not going to fall out. I'm being supported.
Thanks for being with us, folks.
Yeah. Thank you, everybody, for coming along and accompanying me on my journey into KiCAD. And I will see some of you pretty soon at the barbecue, I guess, if you haven't melted on the way here, which is quite possible. So,
Scott Miller said, thanks, John and Mitch.
you're welcome, Scott. We did this just for you. So, for now, first, go and build something awesome, and it's goodbye from me, and...
It's goodbye from Crispian.
Cheers.
Okay. Bye, everybody.